Hey guys, it's Peyton. Let's take a look at solving quadratic inequalities. To do so, let's first look at solving linear functions and then move to quadratic functions. Find the range for x that satisfies the following inequality. 4 is less than or equal to 3x minus 5. All we need to do is simply solve for x. So, first, let's add 5 to each side. So we have 4 plus 5 is less than or equal to 3x. Okay? Let's simplify that a little bit. So 4 plus 5 is 9, and it's going to be less than or equal to 3x. Now we solve for x, so let's divide by 3, and 9 divided by 3 is 3. So we find that 3 is less than or equal to x, or x is greater than or equal to 3. Now let's move to linear functions. For the following equation, graph the inequality y is strictly greater than x minus 3. First, let's take a quick look at everything and analyze the information. We know that y is greater than the function x minus 3. So on the graph, we're going to shade above the line y equals x minus 3. But first, we need to consider the inequality. It's a strictly greater than inequality. So we need to make the line dashed and then shade above. And here's a graph of that. And now we're just going to shade above the dashed line following the inequality. Now, this is going to be a little bit more complicated when we move to quadratic functions. But before we move there, let's do a little recap of inequalities and whether the lines are dashed or full. If we have a strictly greater than or a strictly less than sign, the line is going to be dashed, but it will extend without boundaries. If we have a greater than or equal to or less than or equal to sign, the line is going to be solid. Okay? Let's jump into an example. Shade the area for the given quadratic inequality y is less than negative x squared minus 12x minus 41. First, let's take a look at the graph. And now let's look at the inequality. Here we're looking for y is less than the equation. So we want to shade below the quadratic. And the line is going to be dashed because it's a strictly less than inequality. And here's the graph of that. Looking at the graph, the line is dashed like it would be for a strictly less than inequality, and it's shaded below following the less than. In the previous example, we saw an inequality using y is less than an equation. This isn't always the case. Usually you'll see one where the inequality involves a number related to a function, and you'll be asked to give the x intervals that satisfy that inequality. Let's look at some examples. For the following equation, give the x intervals which satisfy the inequality. 10 is less than or equal to x squared minus 8x plus 17. We can do this graphically, but I'm going to do it algebraically. First, let's simplify the equation by moving 10 to the other side. We'll do this by subtracting 10 from each side. So I'll have 10 minus 10 is less than or equal to x squared minus 8x plus 17 minus 10. 10 minus 10 is 0, so we have 0 is less than x squared minus 8x. And 17 minus 10 is 7, so we'll have a plus 7 here. Now we're going to tweak the problem just a little bit by changing the inequality to a strictly equal sign. Don't worry, we're not going to forget about the inequality. We just have to do that in this part. All right? And we're going to solve for the x-intercepts. And we will do so by factoring. So x squared minus 8x plus 7 equals 0 becomes the quantity x minus 7 times the quantity x minus 1, and that still equals 0. Now to solve for the x-intercepts, so we'll have x minus 7 is equal to 0, and we'll get that a solution to that is x equals 7. And for the other, we'll have x minus 1 equals 0, and we'll find that x equals 1 is the other solution. Since we know our x-intercepts, we can formulate the intervals for inequality. One interval is x is less than 1, a second interval is x is greater than 1 and less than 7, and our third interval is x is greater than 7. Now let's take a look at our previous inequality. 0 is less than or equal to x squared minus 8x plus 7. We're going to use the graph of this function to figure out what x intervals hold true for this inequality. And here's the graph of that. Looking at the graph, the equation is less than or equal to 0 on the interval x is greater to or equal to 1 and is less than or equal to 7. This interval is our answer. Let's do a quick recap of what we covered before we move on. First, given an inequality involving a number and a function of x, we solve the inequality so that it's a function of x equals 0. Second, we solve for the x-intercepts by factoring, or if necessary, by the quadratic formula. Third, from the x-intercepts we can develop the intervals for which we can use as the answer for our inequality. Now we needed this information because though some questions will be graphing questions, most will be algebra based, and some are real-world oriented questions, which uses an algebra approach almost exclusively. Here's a real-world problem. A rancher, Danny, is building a rectangular pen to enclose his chickens. Why he's ranching chickens, we don't know. He does not want the area to exceed 72 square yards and wants the length of the pen to be 1 yard less than the width. What are the possible width measurements of the pen in area? To approach this problem, the first thing we need to do is formulate the inequality. We will let the variable w denote the width, and the length will be equal to w minus 1. So area is equal to w times the quantity w minus 1. But we know that the area must not exceed 72 square yards. So here's our inequality. W times the quantity w minus 1 must be less than or equal to 72. Now we need to solve for the x-intercepts. So let's move the 72 to the other side of the inequality, and it becomes now w times the quantity w minus 1 minus 72 is strictly less than or equal to 0. And let's simplify the equation by distributing the w, and we'll have w squared minus w minus 72 is less than or equal to 0. Now to find the x-intercepts, we need to change the inequality sign to a strictly equal sign, and then you can either factor or use the quadratic formula. I'm going to factor. So w squared minus w minus 72 equals 0 becomes the quantity w minus 9 times the quantity w plus 8 equals 0. And now solve for the x-intercepts. So w minus 9 equals 0, and from that we'll find that w equals 9. And then for our other, we'll have w plus 8 equals 0, and from that we'll find that w equals negative 8. So with this information we can formulate the three intervals. W is less than negative 8, w is greater than negative 8 but less than 9, and w is greater than 9. Now let's look at the graph of the function. This graph may not show a lot, but we know it's a quadratic opening up, so we can conclude by the inequality that the interval for which the inequality holds is w is greater than negative 8 but less than 9. But a width is never negative, so the actual practical interval is w is greater than 0 and less than 9. That's it solving quadratic inequalities. I'll catch y'all next time.